Okay, next we're going to work with vector projections. A little different because before we were working with scalar projections. So first we did scalar projections, then we found the angle between a projected vector and the axis, and then finally we're on vector projections. Vector projections is the same as scalar projections. This is the formula for our scalar projections. The only thing they've done is multiplied by the vector or a unit vector pointing in the same direction of B. So what that means is they're multiplying by the components of B divided by the absolute value or magnitude of vector B. It simplifies into this formula here, which is what we're going to essentially use to solve this. Okay. All right, so let's jump forward to the question. Vector projection of vector OA with values of 4, 3, so in 2 space, and vector OB, values of 4, -1. To make this simpler or refer to our formula easier, I'm just going to rename the vector. This is vector A, and vector B, which is great because now we know that a vector projection of A on B is the formula A dot product of A and B divided by the dot product of B multiplied by the component values of vector B. Okay. So I'm going to try to make sense of this all for you. Vector B's component values, so this is referring to that. Okay? And what ends up happening is, I want you to think of it like this. This number here, or these calculations here, essentially become a scalar value of these components. We're going to find a number in this and multiply it to the 2 component values of vector B. That's essentially our goal in this. So, A dot B. We have the component values of them, so we know we can take the first ones, 4 by 4, multiply them, and then add the second values, which is 3 and -1. Okay. And of course, this is all divided by B multiplied by B. Well, that would be 4 by 4 plus -1 by -1. And again, we'll turn this into a scalar of B. We get 16 minus 3, which is 13. And 16 plus 1, which is 17. And our component values for B were 4 and -1. So now we use this as a scalar and we apply it into the bracket. So this becomes 2 carried a 1, 52 over 17 as our x value. And our y value becomes -13 over 17. The book's example goes into great depth in solving this question. And the reason they do that, I'm going to show you both pages, is because the way the book solves this is by putting it in the first, then rearranging it with the numbers, then rearranging it again, and finally solving. What we did is we just used the last formula, plugged the numbers in, and got to the same answer very quickly. Highly suggest just doing it the fast way instead of the long way. Okay? So if you look in your example number 5, that's the difference between our 2 questions, is they've put it into the first formula and then simplified it going through the way they simplified those letters there. A longer process.